Let's talk about database code and your version control system. All professional developers should recognize the value of using some sort of version control. Even in very small teams, it seems like most application software developers have learned that using a version control system is just prudent and it's really easy. Now, version control systems over the years have improved their ability to manage a whole variety of code types as well as different team development paradigms and methodologies. The last 10 years especially have seen quite a few open source and free systems, really to the point where there's no excuse for any software developer not to use version control these days. Git in particular has gained a tremendous following in the last few years, and even Team Foundation Server provides a Git interface for developers these days. However, we have plenty of challenges in database development that tend to lead people away from working in version control. So let me look at SQL Server, though. Other platforms are very similar. And the vagaries of SQL code itself kind of present difficulties, and many IDEs don't really deal with this. One of the challenges that database developers have with storing their code is in version control, they typically develop in a tool that's an editor, such as Management Studio or SQL Developer, SQL Workbench, something like that. The code they write is compiled on the SQL Server instance, and there's never really a file that the developer has to save their code to. Now, this is different from many other types of environment where a developer typically works with text files that contain code, they save them to a file system, and then they'll compile them, copy to a server, or something else. But in relational development, the code is usually never saved as a file. In fact, the process of getting the code into files can be somewhat cumbersome. We also have the issue of each object in a database is not easily separated into a separate file. For example, tables and databases can have indexes, constraints, extended properties, permissions, types, all kinds of things. And we can alter a table to include new structures, but the code is different and it doesn't always relate. Now, if you contrast this with a C# file, if I add a new method to that, I just add it to the same file and it's all tracked together. We also have a lack of database development tooling, especially for SQL Server databases and other relational engines, but it could occur in NoSQL as well. Management Studio, for example, doesn't easily integrate with version control, and neither do most other editors. Certainly there are some third-party partners that have produced tools for the Microsoft ecosystem and some of the other platforms. SSDT from Microsoft does build on the Visual Studio capabilities, and it has an offline schema model where it does save everything to a file, but all of these methods of working with code require the developer to kind of take action outside of writing code, just compiling it, clicking save, and then committing it. It hasn't been a habit among many developers as well of actually committing code. Perhaps because we may write code and compile it, but developers usually tweak the code in the database. They don't often just go back to a file. We may pull the code back from the database and change it and recompile it. So tracking those changes, committing them to version control, it's not as easy as it sounds. Certainly there are tools to manage this after the fact, but they tend to be brittle, usually tightly integrated into a particular process or a particular project. Also, the database isn't tightly linked to the code a developer works on. So we find developers make changes to databases in order to test code, and they forget to save those changes to the version control. They don't even remember making those changes. All these years of bad habits have resulted in relatively few people understanding and building the habits of how to save their database code in a version control system. In addition, certainly we've talked about the vagaries of SQL language, how it's a little bit broken. And when I write that code, when I make those changes, I don't often include it with the existing code, or if I save it in the same version, I actually need both versions for the code to work. For most of the life of SQL, the language itself is just so fundamentally different that it's just difficult to kind of track those changes. And we'll look at some of these details as we move farther along in the course. Now, the strange structure of the SQL language means that lots of the techniques we also use when we're doing team development with version control, and we try to reconcile differences among team members, are difficult. Merges of SQL code are very complex and typically require a human to decode and decide which changes to choose from each version. This lack of automatic merging means that team development with SQL or with databases doesn't easily scale. Now, a number of developers try to look and link their development database to a version control system, and they also want to implement locking to prevent developers from making changes. This is typically to avoid those merges. But this is a place where version control use then feels very cumbersome, and so developers often start to ignore it. There are many version control systems on the market we've talked about before. All of them fundamentally work the same way. They store versions of files and they allow comparisons and easy tracking of those versions over time. Now, most code is text, so it works quite well. In this code, we're going to use Git, which I like, and it's a distributed version control system, which means that clients work independently and then sync their code with other clients. I'll actually be storing code in Visual Studio Team Services, which is based on Team Foundation Server. We'll use the Git interface to connect there. Now, there are plenty of other version control systems we can use. I like Git, and that's my preference. It's free at this time. But certainly there are other choices you could make. Subversion is a very popular system. Visual SourceSafe and Team Foundation Server from Microsoft are out there. Perforce, CVS, Vault, plenty other systems are out there. Any of them will work. DevOps doesn't prescribe that you use one or the other. It doesn't matter whether you use a centralized or a distributed version control system. Just use some version control. Some are free, some are commercial, and the choice is often based on what you already have in your organization. I recommend you ask your developers what they use right now. Let's find out what the application developers are doing, and then ask for a repository to store your database code. We'll discuss the structure and organization of your repository in future sections. Now, if you've got nothing in place in your company, I do recommend Git. There's lots of resources to help you get started and learn how to use the platform. But above all, just use some sort of version control.